Number 1, a man has a ladder that is 19 feet long. Now let's draw our right triangle. And remember that the ladder is always going to be the slanted side. Slants against the house or the building. So here's the ladder, 19 feet long. If he sets the base of the ladder, meaning the bottom, on level ground 6 feet from the side of the house, from the base of the ladder to the side of the house is the 6. Now here's our x. How many feet above the ground will the top of the ladder be when it rests against the house? So from the ground to the top of the ladder, that is this side over here, which is x. Now this is not a trig problem. It's not sine, cosine, tangent, because we're not doing anything with an angle. We don't know any of the angles besides the 90-degree angle, and we're not looking for it. This is Pythagorean theorem. We're only working with the 3 sides of the triangle, and that makes it a squared plus b squared equals c squared. C is always going to be the hypotenuse, so crossing the right angle is 19. That has to be C, so plug that in. And the A and the B are the other 2 sides, and it doesn't matter which one's which. So I'll make that x and make the other side, or the other variable, the 6. Okay, so we know the 6 squared is 36, and 19 squared is 300 something that I don't remember. So hold on a minute, folks. 19 squared is 361. Okay, subtract 36 from both sides, and then when you do that, you get 325 over here, and you get x squared on the other side. And then you're going to take the square root of both sides, because we just want to find x. So let me put this in. The square root of 325, what do we have to round to? The nearest tenth comes out to be, okay, this is important here. It actually comes out to be 18.0, and I know it seems like it's not important to write the 0, but you have to write it because it says nearest tenth. If I only put 18, that's just the nearest unit, or like a whole number. So 18.0. And there we go with number 1. Okay, we're going to do one more problem together. Let's try number 2. Number 2 is a part A and B, so that's why I think it's a good idea we do this. A stake is to be driven into the ground away from the base of a 50-foot pole. So the pole is the vertical side here. A wire from the stake on the ground to the top of the pole is to be installed at an angle of elevation of 52 degrees. So you can see the angle down here at the base. Part A. How far away from the base of the pole, so here's the bottom of the pole, should the stake be driven in? From the bottom of the pole to the stake, we don't know, so that's going to be our x. And don't even look at part B yet. Let's just focus on part A, finding x. Obviously, we're dealing with an angle, so it's going to be trig. Across from your angle is the opposite side, and next to the angle is the adjacent side, so it's going to be tangent. So tangent of, I'm going to plug stuff in right away. Tangent of theta, now theta is the angle, so it's going to be tangent of 52 equals, and tangent's opposite over adjacent, so it's 50 for the opposite side over x for the adjacent side. So then we're going to put this over 1 and cross multiply. So tan 52 times x. I'm giving a shout out to somebody. They know who they are. Nia, yes, it's you. Shout out to Nia from 6th period. He's been asking for it for, I don't know, 2 months now, and I'm finally making a new video, so there it is. Okay, so cross multiply the other side. 50 times 1 is 50. And we're going to then divide both sides. Opposite of multiplication is division. Divide both sides by tan 52. Over here. And let me put that in the calculator and see what we get. So you just put in 50 divided by tan 52. 50 divided by tan 52. I got, what do we have to round to? Nearest foot. So it comes out to be just 39 to the nearest foot. Okay. So we've done problems like this before. Really, the reason I'm doing this question is for the part B. Part B says, what will be the length of the wire from the stake to the top of the pole? We want to find the wire. Here's the wire. Now, this is really important. Do not label it X, because we already have an X down here. And if I put X here, I'm saying they're the same length, and they're not. So you want to just label it as Y. Now, what we're going to do is trig again, but the diagram is looking kind of messy now because you have an X in there and a Y. So sometimes what I do, and I'll just do it off to the side here, I like redraw the diagram and just put in the numbers that we're going to need. Okay, that's way too small. Like, I'm not going to, hold on. How do I go back? Like, I'm not going to be able to label with that. Oh, okay, I'll just go here, I guess. That's not even much bigger. Oh man, another great video. Okay, the angle is 52. It was basically for this, but I can fit it in. All right, we don't know this side. This is y, and then the x, or sorry, this side here was 50. So I just think it's a lot easier redrawing it and just looking at the 50, the 52, and the y, as opposed to all like this other stuff, wires and stakes and poles and yeah. All right, trig again because we have an angle. Crossing the angles opposite, and across in the right angle is hypotenuse. So now opposite hypotenuse, that's going to be sine. I'm kind of running out of room, so I'm just going to plug stuff in right away. Sine of theta, theta is your angle, which is 52, equals, and it's O over H, so opposite goes on top, and then hypotenuse on the bottom. Cross multiply again, over 1. Sine 52 times y, and 50 times 1 is 50. Divide both sides by the sine of 52, and then we just have to put in the calculator. Like I said, the main reason I'm doing this is because I want you guys to make sure that you know in a double problem, you call it y. Okay, y equals, I don't know, 50 divided by sine of 52, and I get nearest foot again. Yeah, nearest foot is 63. By the way, if anybody was thinking, hey, couldn't we do Pythagorean theorem part B? You actually could. Ignore the angle, and then you know the bottom side. Because if you go to part A is x is 39. So you could use the 39 and then the 50 and then the y, just the three sides, and it'd be Pythagorean theorem. Most people don't like doing that way, and they don't really think of it. They just like doing trig twice, so that's what I did. I hope you guys enjoyed the video. I didn't really have anything funny. Do I have something funny? Funny. Kept. There you go. Kept. Only 7th period knows what I'm talking about. Bye.